Another day, another trig problem. So let's take a look at our equation. We are given that sine of 5x must be equal to cosine of 7x. We know that x is bounded on the interval from 0 to 2 pi, and we are asked to find the value of x that satisfies this equality. So whenever we are dealing with a trig equation, we want to have the same argument, which in this case we don't. We have 5x and 7x, so not the same value, or the same trig function. So is there a way to go from sine to cosine? Well, actually there is, and it's a well-known formula that tells us that sine of 5x must be equal to cosine of pi by 2 minus 5x. But we know that cosine is an even function, so this is also equal to cosine of 5x minus pi by 2. Okay, with this in mind, we go back to our initial equation and we get cosine of 5x minus pi by 2, and that's gonna be equal to cosine of 7x. So from here we can say that 5x minus pi by 2 is gonna be equal to 7x plus 2k pi, where k is an integer, where k is some integer. Find the value of x. With the value of x found, we know that's bounded between 0 and 2 pi. We can find the value of k, go back into our form of x, and find the solutions. But this way of doing it is not gonna give us all the solutions, if you believe me or not. So tell me in the comments, why is that? Okay, now back to our equation. Let's move everything to the left hand side. So we discussed that this is not the way to go. Now moving everything to the left hand side, we get cosine of 5x minus pi by 2 minus cosine of 7x, and this must be equal to 0. Now it would be helpful if we can go from a difference to a product of some sorts. Well, there is this formula that goes from the difference of cosines to the product of some trig functions, but I don't remember it, so let's derive it ourselves. Let's take a look at the cosine of the sum of x and y. Cosine of x plus y, and I hope all of us know that that's equal to cosine x cosine y minus sine x sine y. And now let's take a look at cosine of x minus y, and that's equal to cos x cos y plus sine x sine y. Now from subtracting those two identities, we get that, subtracting the second from the first, we get that cosine of x minus y minus cosine of x plus y. We know that this is gonna be equal to, the terms with cosine cancel each other out, and in the end we get 2 times the product of sine x and sine y. And now if you let a being equal to x minus y and b being equal to x plus y, from those two, by adding them up, we get that x is equal to a plus b over 2, and from subtracting those two equations, we get that y must be equal to b minus a over 2. So with this in mind, our identity becomes cosine of a minus cosine of b. This must be equal to 2 times sine of a plus b over 2 times sine of b minus a over 2. In our case, a was equal to 5x minus pi by 2, and b is equal to 7x. With those two, we get that cosine of 5x minus pi by 2 minus cosine of 7x is gonna be equal to 2 times sine of 7x plus 5x minus pi by 2 all over 2 times sine of 7x minus 5x, minus minus gives us a plus, so plus pi by 2 all over 2, and we know that this must be equal to 0. So after simplification, we get that 2 times sine of 7x plus 5x gives us 12x divided by 2 is 6 so 6x minus pi by 4, and times sine of 7x minus 5x gives us 2x, divided by 2 gives us x, plus pi by 4. This must be equal to 0. Now we have two cases. So case number 1, in which sine of 6x minus pi by 4 is equal to 0, and that implies that 6x minus pi by 4 is equal to what? Well, at what values does the sine function cancel out? We know that sine of x is equal to 0 when x is a multiple integer of pi, so we say that 6x minus pi by 4 is gonna be equal to some k times pi, where k is an integer, and from here we are going to solve for x, so 6x is gonna be equal to k pi minus pi by 4, get a common denominator, and we get pi times 4k minus 1 divided by 4. That implies that x is gonna be equal to pi times 4k minus 1 all divided by 24. Now we remember that x is bounded on the interval from 0 to 2 pi, and that implies that 0 is less than or equal to x, which is less than or equal to 2 pi. And now with this form of x, we go into our double inequality and find the values of k, for which x is found on the interval from 0 to 2 pi. Substitute those back into our form of x and find the solutions. So we get that 0 is less than or equal to pi times 4k minus 1 divided by 24, which is less than or equal to 2 pi. We divide both sides by pi, and we get 0 is less than or equal to 4k minus 1 divided by 24, which is less than or equal to 2. We multiply by 24, and we'll get 0 is less than or equal to 4k minus 1, which is less than or equal to 2 times 24, which is equal to 48. We add 1 to all the terms, and we'll get 1 is less than or equal to 4k, which is less than or equal to 49. Now we divide the double inequality by 4, and we'll get 1 over 4 is less than or equal to k, which is less than or equal to 49 divided by 4. Okay, so some of you may have pointed this out already. This should be a plus pi over 4, so this is plus 1, plus 1. Here is a plus, so plus here, plus, so we are going to subtract 1, and we get negative 1 is less than or equal to 4k, and on the right hand side we get 47, not 49. So we'll have negative 1 over 4 is less than k, which is less than or equal to 47 divided by 4. But we know that k is some integer, and from those two we can conclude that k must be equal to 0, 1, 2, so on and so forth, up to 11. 11 is the last term that satisfies this inequality and is also an integer. With k found, we can go back to our form of x and find the solutions. So for k being equal to 0, we'll get x sub 0, which will be equal to pi times 4 times 0, which is 0 plus 1, so pi over 24 over 24. When x is equal to 1, we'll get pi times 4 plus 1, which is 5, so 5 over 24 pi. When k is equal to 2, we'll get x sub 2, which will be equal to 9 over 24 pi, which simplifies to 3 over 8 pi. When k is equal to 3, we'll get x sub 3, which will be equal to 13 over 24 pi. When k is equal to 4, we'll get x of 4, which will be equal to pi times 4 times 4, which is 16 plus 1, so 17 over 24 pi. When k is equal to 5, we'll get x of 5, which will be equal to 21 over 24 pi, which simplifies up to 7 over 8 pi. When k is equal to 6, we get x sub 6, which will be equal to 25 over 24 pi. When x is equal to 7, you get the point. When x is equal to 7, when k is equal to 7, we'll get 29 over 24 pi. When k is equal to 8, we'll get x of 8 which will be equal to 29 plus 4, which is 33. So 33 over 24 pi. When k is equal to 9, we'll get x sub 9, which will be equal to 37 over 24 pi. When k is equal to 10, we'll get x sub 10, which will be equal to 41 over 24 pi. And finally, when k is equal to 11, we get x sub 11, which will be equal to 45 over 24 pi, which simplifies to 15 over 8 pi. Now, these solutions can be found using the method that we discussed earlier, but we see that we are left with another term that can be equal to 0, and that's it, sine of x plus pi by 4. So we remember that we have case number 2, in which we had sine of x plus pi by 4 being equal to 0. So that implies that x plus pi by 4 will be equal to another multiple integer of pi. In this case will be m times pi, where m is an integer. We find the value of x, we do the same thing all over again. So x must be equal to m pi minus pi by 4. We give a common factor of pi, so we'll have pi and get a common denominator, pi times 4m minus 1 all over 4. But we know that x is bounded on the interval from 0 to 2 pi, and that implies that 0 is less than or equal to x, which is less than or equal to 2 pi. We substitute the form of x that we found, and we will get 0 is less than or equal to pi times 4m minus 1 over 4, which is less than or equal to 2 pi. We divide the entire double inequality by pi over 4, and we'll get 0 is less than or equal to 4m minus 1, which is less than or equal to 8. Now we add 1 on both sides, and we'll get 1 is less than or equal to 4m, which is less than or equal to 9. We divide by 4, and we'll get in the end 1 is less than or 1 over 4 is less than or equal to m, which is less than or equal to 9 over 4. But we remember that m is an integer, and from those two we can conclude that m must be equal to either 1 or 2 for our two properties to be satisfied. So when m is equal to 1, we'll get x sub where were we? X sub 12. So x sub 12 will be the case when m is equal to 1, and we'll get 1 times pi minus pi by 4, which will be pi minus pi by 4, which gives us 3 pi by 4. And x sub 13 will be the case when m is equal to 2. So you get 2 pi minus pi by 4, which is 8 pi minus pi by 4. So we'll get 7 pi by 4. And that's it. We found all the 14 solutions of our equation. And if you don't believe me, let's take a look at the graph of y being equal to sine of 5x minus cosine of 7x on the interval from 0 to 2 pi, and see that it intersects the OX line 14 times exactly at the values that we found earlier. What a beauty. So thank you for watching. Don't forget to like and subscribe. See you next time. Take care.